So our next talk is on continuous delivery with Kubernetes by Archana and Sukanya.
Good evening, everyone. Me and Archana, we are here to talk about how to achieve continuous delivery with Kubernetes. So, before we get started, let's have a quick survey on how many of you here are familiar with Docker, Kubernetes, and Helm. Raise your hand. Okay, great. For those of you who are already familiar with this is just going to be a brush up of the basics for you. So, let's get started. From Vinny's talk, all of us would have got an idea of why containerization of your application is very important. So, Docker is the tool to achieve containerization of applications. So, it's an open source tool, and the learning curve of it is not so steep and it's pretty easy to use. So, uh, why are containers essential? Containers are essential because, on comparison with VM, the virtual machines, they are a lot more lighter and cost efficient. You don't need the hypervisor unlike the VM, and your Docker takes care of creating the containers by sharing the resources on the host machine on which it is run. So let's quickly move on to the components of Docker. When talking about the Docker engine, the Docker daemon is like the brain of the Docker. Whenever I try to run a container, so what happens is that there is a Docker client, which in turn invokes the Docker API, and that which is redirected to the Docker daemon, which receives these requests and then processes them and allocates the resources and other things necessary for us to create a container. Talking about the Docker object, uh, there are two important objects when it comes to Docker, which are going to be the image and containers. So, image is basically a snapshot of your container, and when you run an image, you get a container. So, how do you create an image? Is that you have a Docker file and it has no syntax, and you give all the necessary information that is required for your application to be containerized. So, you can store and version all of your images in a Docker registry. So this Docker registry can be a public registry or it can also be a private registry, and you can host it on many of the cloud providers. Alright. Okay. So before we move on to Kubernetes, let's have a quick demo with Docker of a simple Hello World program to try. Let's start with the Docker file. So, how do you write Dockerized applications back? So, you always start from an existing public base image or a private image, and you start layering on top of it. So, as you can see, I have a from tag which refers to a Python 3 public image. So, and then I set my working directory, and then I copy all the necessary files, and then I run the step to install all the packages, and then I expose the code on which I am running my application, and then finally I have the cp tab to run the command that has to be run to start the application. Alright, so this is pretty much how you write a Docker file, and to run it I have to first build my Docker image. Okay, so this is the syntax of how you, this is a command to build your Docker image, and this is going to be the name of my image, and by specifying -t, I can tag my image, that is basically version it, And then, since my Docker file is in the current directory, I'm just pointing it to the current directory. Okay. So it starts from the base image and it creates layers and stepwise on top of that base image. So now, so this is the command to run an image. I'm just going to run it on my host machine. And so by specifying hyphen p, what I'm trying to do is I'm trying to bind the port of the container to the port of my host machine. So on the container, it's going to be running on 8089, and I'm binding it with the 8090 port of my host machine. Okay. So this is pretty much how you get it out. Alright. So let's move on to Kubernetes. So just take any typical application. If you think about containerizing your application, you definitely end up with a lot of containers. And obviously, there has to be a there cannot be a manual way to schedule and manage all of these containers. So you will definitely have to automate it. And Kubernetes is the way to automate your job, uh, automate and schedule your containers. Basically, an orchestration platform for your containers. And the learning curve is quite steep compared to that of Docker, but there are a lot of resources available on the internet which should get you started on Kubernetes. So, um, while entering into the world of Kubernetes, there are a lot of terminologies which keeps repeating itself again and again. So let's start with pod. So the pod is when you dig down deeper, it is present at the most granular level in the Kubernetes. So a pod is basically going to be a collection or the basic running entity. It's a collection of your containers, and it also contains the policy for creating and managing. I mean for creating the container. And then there is replication, the concept of replication. So whenever you're creating an application, right, you need to make sure that there are a set of pods always available, and there should be a way for us to replicate the pods whenever there's a failure of data. So this replication traditionally followed a lot of strategies to follow. I mean, the replication was attained by following a lot of strategies, and we started with the replication controller, which made sure that the number of pods that are required were always available. And then we moved on to replica sets, which was just an upgrade of the replication controller. And then finally, we got to deployment. So in Kubernetes, everything, all the specifications are basically in terms of YAML. So this deployment is yet another YAML, so which takes care of the pods, maintaining the pods. So whenever the pod shutdown rate, and even if I manually go and kill my pod, and if there's a deployment, this will always make sure that you can restart the pod and recreate the pod, and always ensure that the requirement pods are always available. So then there's the service, which is an abstraction of a layer above all the requirements and the pod. And this also has the set of policies and the way by which you access these services. So be it within the cluster or from outside the cluster. And then there's the concept of interface. So interface is basically a set of rules and is an API object which specifies all the policies that is required for handling the traffic and load balancing and yeah. So basically, it talks about how do you what's coming from the internet and how does it go and reaches the service. And uh, let's take a look at the architecture, Kubernetes architecture. It follows a master worker communication setup, and so the essential what are those services that are or the components that are present in the master node will be your queue controller manager and the cloud controller manager. So the queue control manager is basically binding type of all the other controllers. So logically there are a lot of controllers like the node controller, which makes sure that the number of work nodes are always available, and you have the service controller, and this is going to be one single type to which manages the other controllers. And the cloud control manager is the one that deals with the container that talk to the underlying cloud provider. So uh, the cloud controller manager is the one that helps you helps Kubernetes stay independent and be flexible to switch between cloud providers. And you also have a Linux controller, but unlike the other controllers, you don't get the controllers by default whenever you create and whenever you host a Kubernetes application. So this Linux controller has to be a custom defined controller, which is going to be very specific to the type of application that you want to use. So one such example can be Linux. And then you have the EPC, which basically maintains the state of your cluster, and you have the API server, which talks to the client, which will be the cube serial. So the cube serial is the client that is going to be running on the host machine, and then that is going to talk to the cube API server. Then you have the queue scheduler, which takes care of scheduling and allocating the resources to the pods. So these are the components that are primarily present in the master. So in the client nodes, you have the kubelet and the kube proxy. So the kubelets are basically there to ensure that your containers are running inside of it. And the queue class is basically going to be a set of rules that are present in the cluster to handle the interaction between the services and basically set of rules that are required. Okay. So, as we discussed earlier, service is which is the abstraction, and which also tells me which also tells me about the axis of my pods. There are different types of service that you can create. So, let's say I want to run my service of type in cluster IP. So by default, the cluster IP service type will not expose your service to the outsider. So this is going to be accessible only within the cluster by the service. So then you have the node code. So this node code is going to give you a static code, and what it does is whenever there is a request coming to the cluster, coming to the service of type cluster IP, it is going to forward it to that of your node code type service. So how it binds is basically when you create a service of this type, it's going to give you a node IP and it will also give you a port. So you access it that. So then you have the load balancer. So the load balancer is a way to expose the service to the outside world. So what happens is the underlying cloud provider is going to give you load balancer on top of it, and so you basically get the data once you deploy it. and you expose it of type load balancer, you can get the context of this service given an external IP, and via the IP you'll be able to access your application. Right. And the external name is basically giving a named domain to your service, and this will not meet any of the properties. Okay. So before moving to help, let's have a quick demo with Kubernetes. Okay. So, okay. So this is how I run my application through Kubernetes. So this is the name of my service, and what image am I going to run on it is given here, and then on what port is the service being. So this talks to the underlying cluster and creates a deployment. So now all that I've done is I've just created deployment and I've not exposed it yet to the outside. So to expose it, I again run a command and I expose it by setting the type of the service to load balancer. Okay. So now I made sure that I am exposing my uh, deployment controller by giving it a service of type load balancer. Okay. So then now if I try to get the context of my service, it has something called as an external IP and it's yet to be assigned for it. So yeah, so then once you get your external IP, then you'll be able to access it through your browser. Okay. So so we saw that help Kubernetes is completely YAML based. So help is going to be something like the app-get or homebrew for Kubernetes. So this manages your the Kubernetes application by something called as the charts. So charts are nothing but they're basically templates and template. The whole L works on the template engine way, wherein everything can be visualized and you can just pass on the values whenever you try to make a deployment. So and also uh, charts are just like Docker images. I can have a repository for my charts. I can version them and I can share it and I can share it publicly. And also for a lot of our day-to-day application, I have a help repository, public repository, wherein the charts are available and I can just start using them. So the help basically has a server and a client. So the server is going to be my tiller server, and my client is going to be my help client. So I run the help. I run the commands from through the help client, and it talks to the tiller service, and which then substitutes all the values and basically creates the YAML and it starts and it deploys to the underlying Kubernetes cluster. So now let's take a simple demo of this one. So I what do I have to do is I have to make sure that my Tinder service is first running on my cluster. How do I achieve that is I start with help minute. So it tells me that the till is already installed in the cluster. So let's take a look at the chart files that I have. So this chart is basically going to be it's again composed of YAML, but there's a structure in which this chart is created. So when I go ahead here, I'll have a chart created, and I can create a chart from my application, and then it will basically have the set of predefined YAML, and I can tweak it and remove all the ones that are not necessary, and just add to all these values that are necessary. So if you can see, you first have the chart YAML file. So this will give me the version and description and API version, that the Helm API version, and then I have my values of YAML. So this values of YAML is going to contain all the necessary information that are required for my service YAML and the deployment YAML. So it's pretty simple since our application is just an hello world application. You have the replication count. So the replication count is the one like I previously mentioned. This talks about how many pods are supposed to be up all the time. And then I have my image details. So this given that there's enough access for me to, for the helm to talk to the registry, Docker registry, I give my image, and then I give the tag associated with the image, and then yeah, you have various full policies for your image. So this full policy, right? The suggested way is, I mean, the most commonly used full policy is going to be if not present. So this basically ensures that you pull the image only if you don't have the image already. And yeah, you can also change it to always and make sure that you keep pulling the image only. And then yeah, so since we want our service to be exposed, so I give the values to them as load balancer, and I expose my port as well. Right. So then I have my service YAML wherein I have these values being substituted, and so when I run a helm install or helm update command, I basically substitute these values, and I create my YAMLs that are required for Kubernetes to understand. So just like that, I also have my deployment YAML to take care of my replications. So this again is going to talk to the values .yaml file, then substituting create the necessary template that are required for my Kubernetes service. And so you can also package them and package this whole helm. And if you try and package your charts, right, it's just going to be a zip file with a version associated with it. So let's say I'm just going to do helm install. So yeah, this is just going to give me all the details of what my service is, what's the deployment, and what's the pod that are created, number of pods created, and what is the state of the pod. So I've already added my helm repo, and so when I do this bit, hello world and the hello world chat, what happens is it looks at the repo, and it sees and deploys the latest version of the repository. So that will be from the main to mention.
Building to all. So with all the gyan that we had with containerizations, Docker, Kubernetes, and help, let's see how we can set up a pipeline for Kubernetes and take an application that is running in your local to a cluster that is running in a cloud infrastructure. So I'm just going to start off with giving an overview of how a traditional CI/CD pipeline will look like. So yeah, absolutely, we have a source code running in our machine, and we push it to a Git repo, say GitHub or GitLab, and then you have stages in your pipeline. One of being the build stage where you run the test like unit test and integration test and so on. And then you move on to the next stage where you package your application. That is, you take your source code and all the dependencies that you need for your application. If it is a Java, you need a dependencies and also. And you made a package of out of it. In case of Java, it's a Java or binaries or whatever it is. And then next stage being the deploy stage where you find a system or a server where you can deploy this application and see it running. And yeah, that's it. The pipeline is there. So certain problems with the traditional CI/CD pipeline setup. Let's say we have an application that's going to handle a large number of traffic. So you need to have replicas, as in you need to have four running entity of the same application, so that you can load balance your traffic to all these four nodes, right? So in such cases, in a traditional deployment system, you have automations, and you still have certain nightmares like how do you manage resources between all these four nodes, and also if at all one node is going to go down, how I'm going to bring it up by monitoring the service all the time. All these are existing present in the traditional CI/CD pipeline cases. So let's see how we can easily overcome with these with the help of Kubernetes. So this would be the pipeline setup for Kubernetes application. So I have my local code and a local setup, and I'm pushing it to my Git repo, and the tests are running. And the next stage, build stage, here is when I build my Docker image. So I will be having a Docker file with every application that I have, and I build a Docker image out of it. Once I build this Docker image with all the dependencies needed for that application, I will push this Docker image to a Docker hub. A Docker hub is nothing but just like a repo. Just like how we have a Git repo for our code, you have a Docker hub or a Docker registry where you push your Docker images. That's it. And the next stage is our release stage. So how Sukanya showed us how we can use Helm charts to deploy your applications to a Kubernetes cluster. We can package the entire application with the help of Helm charts. So you have your different set of YAML files, right? Service YAML, deployment YAML, where you can specify which version and which Docker image I have to use for this application. And I just pass those things as values to my chart, and I package it as a artifact, and then I push it to a repo. Again, this is going to be a chart repo where I'm going to push all my Helm charts so that I can take the chart and deploy whenever I want it, right? So, and I could also version it. So, say one version of chart will be deployed in dev, and the next version will be deployed in production, so on. So I'm going to push my chart to repo, and then comes the deploy stage. So what would I do in deploy? So in an ideal world, you will have a cluster setup in some cloud provider, right? You can have individual clusters for individual environment. Say one cluster for dev environment, one cluster for QA environment, or you could just run all the environments in a single cluster. So you pick up the Helm chart from the chart repo, and then you say Helm install of this chart into this cluster, and yes, boom, your application is now running inside your cluster. So the disadvantages that we discussed with the traditional CI/CD pipeline. Let's see how Kubernetes helps us in abstracting out all those things and takes care how it internally takes care of them. So yeah, I just wanted to show a cute big demo before that. So this is just a repetition of again the same thing. I have a simple Python application which is which is it's just running a single endpoint where it says hello from version 1. I'm also going to versionize my application. It says hello from version 1, and it's also printing from which machine it's getting served. So since I'm going to talk about replicas, my application will be running in different pods. So I need to know from which pod I'm getting served. So I'm just going to print that detail as well over here. And yeah, it's a serving me the host. This is the application, and this is the Docker file, simple Docker file, same as that of the other one we saw earlier. And I have my Helm chart here. So as we already saw, Helm is just a template engine. You give Helm a set of YAML files like a template, and then you give set of values. It just templatizes those files with the values and just creates a YAML and uses those YAMLs to create resources in the Kubernetes cluster. So each file is a resource. Deployment is a resource in terms of Kubernetes world. Service is a resource in Kubernetes. So here is my values.yaml. So I'm going to say that my application needs replica count of 5, which means I need 5 running entity of my application. And I'm going to use this image called hello world and version is 0.1 and the full policy and whatever. And I'm going to use the service type node port, one of the which she explained before. And internally the service is running in 5000 port and I'm going to external exit using the port 83. This is the values.yaml file and this is my service YAML. I'm just it's going to use the values for the values type. So when I say values dot service dot external code, it's going to pick that value and put it over here. So you get a populated template which is then deployed into the which is then used to create resources in Kubernetes. So that's all. And so I'll just say so I have my chart over here. I say helm upgrade install. So I'm going to say if one release already exists, upgrade it. Otherwise, install a new version. I'm giving a name for my release, which is called release itself, and I'm going to use the chart hello world chart. When I hit this, so it created a container for me. I can show it. So if you can see, it created 5 pods for me. Created 5 pods for me, and my service is running in all 5 paths. So in order to hit the service, I'm just going to find the node IP and node port in which my service is running. So it says hello from version 1 and is served by so and so part. It's one of the parts that is being listed over there. It could be one of the 5, right? So are we clear so far? Is there any questions? Okay. So next I'm going to talk about certain deployment strategies. So what are deployment strategies? In the normal world that we deploy our applications, we adopt certain strategies based on environments and also based on the application needs. So I'm going to talk about 5 strategies now and how is it done in now and how can we do it in Kubernetes. Okay, so for the first one being the recreate strategy. So let's say I'm having an application, version 1 of my application, and I have a load balancer attached to it. So as of now, whatever traffic hitting the application, it has been balanced to all the 4 nodes of the same application. In the recreate strategy, what I do is I delete all the nodes and then I create version 2 of 4 nodes of the same application, right? So what could be the drawbacks here? I have a downtime. So when I'm deleting all the nodes, there are no nodes to handle my traffic, right? So there's a downtime for this way of deploying strategy. So this would be this is simplest way of deployment, and this could be adopted for a dev environment, right? So yeah, next strategy. Next being the ramp the slow rollout. So what we do here is we delete one node of V1 and create one node of V2, and then you go on in such a way. So you delete one V1 and you create one in V2. So in this way, you are just ensuring that there are some nodes to always handle your traffic, right? So there is no downtime for your application while you're doing the deployment. That's fine. But what could be the problem in this strategy?
Different versions.
Yes, exactly. So some of my traffic would be routed to version 2 and some of them would be routed to V1 and I would see inconsistencies in my application. So there is one more strategy called blue-green strategy. So what would I do is here, I would create 2 nodes of, I can specify the percentage, like 50% of V1 and 50% of V2. And then I would say at a point of time, it points only to certain version of traffic. So At a point of time, it's pointing to V1, and in the next step, it's pointing to V2. And I can test out V2 whether everything is working in V2 as expected. If it turns out good, then I'll make all the codes to green. Otherwise, I'll roll back to my previous version. This is the blueprint deployment strategy. This is one of the most adaptive strategies for production because there is no downtime. Also, we are avoiding the worsening issues. One more strategy called canary is there. So canary is more like you deploy one new version in production and then see how it is being accepted by the users. And based on the responses, you either take it entirely to the new version or you go back to the older version. For that purpose, you just turn certain percentage of your node to new version and route the traffic and see how far it is going. And then based on the responses, you either roll back or go forward with the new version. This is one type. And the last one that I wanted to discuss is A/B testing. So as the name says, it's like you are giving two variants of same thing. It's more like a canary, but the one thing is that you just route the traffic on of specific users. Say I'm just going to route the test users to the new version and test and see if it's turning out well. And then I'll migrate to the new version. So it's like you filter the traffic based on cookies or headers, and then you point them to the new version only. So these are the five strategies that are generally commonly used in our traditional deployment systems. So what could be what are the difficulties or the hurdles that you see with these strategies in a normal traditional pipeline system? Any points that anyone would have faced?
You have to manually do the up and down of the server.
Yes, exactly. So you will have to take care of routing the traffic to the correct node. How would you do that? And also the resource management. All that comes in picture,
And
right?
you don't utilize all the nodes all the time.
Yes, exactly. So yeah, let's see how Kubernetes can help us with this way of deployment strategies. So I'm just going to watch over the pods and the replica set that are running in my cluster. So I have to reduce the size. So it shows five pods running and one replica set that takes care of these five pods. So my desired state is 5 and my current state is 5 and five pods are ready. Even if I delete one of those pods, let's say kubectl delete pod. So it got deleted. So you could see one of them is terminating and immediately one more is getting created immediately. Because the replication controller will see that one pod is going down and it creates one more new pod immediately. So this is just the replication controller. Let's look into how we can adopt one of these strategies. So I'm just going to try out the recreate strategy first. Okay. So I'm going to specify this recreate strategy in the deployment level. So it's because deployment specific. So here below the replicas, I'm going to say strategy and then type as recreate. And then, yeah, that's it. I'm going to save this. Okay. I'm going to change my sorry. I have already created the version 2 and version 3 of the same application. Just that it's going to say hello from version 2 and hello from version 3. But I've already built the image. I'm just going to say deploy version 2, image of 0.2 tag with the newer deployment strategy. So when I say helm upgrade install,
is release hyphen
Sorry, please.
release hyphen hello world chat. Your command is release space hello world hello hyphen world.
But the one I record is saved already. It has name of space.
So I think you put a hyphen somewhere.
Some spacing issue, I guess. Just a minute. I have specific. Sorry.
You have to get it in the code.
No, it's not. It doesn't require codes.
Physical server
Some spacing issue. So I have given it like
space and tabs, the brain of all programmers. Visual Studio doesn't cost.
okay, yeah. If we could see here, sorry, it went off. So it recreated all the. Maybe I can do it once more by changing the version. Mm, Let's go back to version 1. And I also like to put a watch over the command for request. So it's now serving from version 2. I have 5 pods running. And now I'm going to again go back to 1. So it's terminating one by one and then it will create one by one. Since I have stated it is to be recreate. Creating the container from the one. You see, it's now the response is from version 1. Now let's try out the rolling update strategy. For rolling update, I need to specify two parameters. One is max search, which specifies how many nodes that I could take down at a time and bring up. So I'm going to say max search to be 1 and the maximum number of unavailable nodes that I can take. I'm going to specify to be 0. Right? I'm going to again change it to version 2. So when I say I'm here instead of this chart, so you could see it's terminating one and creating one, terminating one, creating one more, and the responses would also vary because one at a time it could be served from version 1 server or it could be served from version 2. It slowly brings them up to the newer version. So similarly, you could try all the strategy types that we discussed today with Kubernetes, and few the strategies like A/B testing and canary requires few more efforts. It's not just like just changing the type to from decreate to rolling update. It requires few more manual steps. So I'm just skipping the demo for them now. With that said, let's get back. Okay, this is just a sample of how we could do blueprint with Kubernetes cluster. So there is something called selectors in Kubernetes. So as we saw, we have a pod as well as a service running. So we need a way for the service to find the pod so that it can expose it to the outer world, right? So how it does that is it uses the label. So each pod will be labeled with some name, and you give this, you tell the service that you have to expose the pod with this so and so label. So that is how we specify. That's why we specify this term called selector. So we say selector belonging to this app, and you could specify a label also there. So label with this pod, you expose them, and you can where you can also specify the version. So let's say now we have three versions running version 1, three pods running version 1, and two pods running version 2. So you could create one deployment that says expose the service, expose the pods only with version 1. So you test them, sorry, version 2, you test them, and then if it goes out well, again you do another deployment of exposing all the pods with version 2. That's how you can take care of blueprint deployment with Kubernetes cluster. So with all this said, yeah, there are other things that I wanted to discuss. So any application would require configurations as needed for them to run, right? So even for a backend application, it requires the configurations such as the database to which it connects to and host, password, everything. So there are two concepts in Kubernetes world. One is config maps and other one is secrets. So you could separate out these configurations from the source code and handle them separately. Let's say I need my database name and host name as a config for my application. I create a config map out of these two key value pairs. So config maps are nothing but key value pairs. I just say Kubernetes create a config map out of these key value pairs. It creates and keeps it there as a resource. And when I may deploy my application, I could say that for this pod use this config map, or you could also mount your configurations as files inside your pod itself. You might need a certain file as to be needed as rendered as a configuration for certain applications. In such cases, what could you do is you could create config maps with those files and mount them at a particular directory. Let's say temp slash some file, and then inside the application you could say that take a configuration from so and so part, and hence your application runs on it. Secrets are mostly same as config maps, just that it is they are base64 encoded, just to ensure security so that it's not exposed to the outside world. That's it. And there are so many other things that you could explore in Kubernetes. Like you have a kube proxy, kube DNS. These are the kube DNS is used to expose each service internally inside the cluster. So how one service can talk to another service. So basically in a microservice architecture, you could just expose one service to the outer world and rest all the services should talk internally and they are not exposed outside. And all the traffics are routed from the single service that has been exposed to the outside world. And yeah, that's all we had. Any other questions?
Um, so going back to slide it, Sukanya. So in the diagram about Kubernetes,
Mhm.
about the master,
Mhm.
is there only one master?
Yeah, a cluster will always have one master, and you can have as many nodes as you want as your workers.
What happens if you restart the master?
Restart the master. I think you can. It's just like restarting any other node. It restarts all the services like the queue controller or the cloud controller. Or
Does it affect the queue
no,
clients?
no. So even if you restart the queue clients, what it does is it just reschedules all the containers that has been running inside previously, and all the services will be up after some time.
The state is always maintained.
That's why HCD is there,
Yes,
right?
yes.
Okay. So when I install the Cube client,
Mhm.
I tell it what the master
Yes.
is.
So this can be done using the something called that is kubectl context. So whenever even if I'm using a kubectl command, right, it needs to know to which cluster it has to connect. So you can also switch from a cluster to a cluster. So there is some command called export config or set context, I think. So with the command you can set to which cluster it has to talk to.
So that is configurable at the client,
Kernel, yes, client.
client level.
Yes.
So coming to Docker specifically, in Docker, is it a pattern to have only one application per container, or is that an anti-pattern?
It's always recommended that you have one application per container. It's like container is the sole responsibility is just running one application. It brings isolation, right? So containation is brought for the concept of isolation. So you always have one application and its own dependencies in a container. Just that.
But then, if you take a container,
Mhm.
you are installing say Linux, you are installing a Linux
Mhm.
operating system,
Mhm.
right? Like RHEL or Ubuntu server. Then you are installing a runtime like JVM,
Yes.
right? On top of that, you are installing the app.
Yes.
So all that just for one app. So if I have a bouquet of microservices that run on the JVM, would it be better to just put it on one container?
Why would I do that? Because if in that case there are certain things like you have a base OS and you have a JVM, you would build an image out of these two at first place, and then use this image as a base image for all the applications that you have.
Okay, so build a base image like the Python 2.73
Yes,
used in
you
your.
can have your own base image, right? So if you are feeling that out of all the services that you have, so there are certain things that's needed across all the service. You construct a base image out of it, and for all the service, you use that image as a base image.
And Kubernetes, does it do discovery like VDI or RTC? Like you
Yeah,
talked about,
Kubernetes.
that is Kubernetes.
Yes, so it's for service discovery inside the cluster. So what it does is whatever name that you are giving in the service YAML, right? So each resource has its name. So that's the name of the service that you are actually running inside.
So coming to that YAML,
I'm sorry to this. Like we have another talk, so
okay.
questions of him, please. Thanks.
And I just wanted to give